Welcome to the Deep Dive. Today we're tackling, well, one of the world's most fascinating ingredients, saffron. You know, red gold.
Absolutely. It's famous for that amazing color, the unique flavor, that really distinct aroma. It pops up everywhere, fine dining, traditional medicine.
Cosmetics even. But that allure and the sheer amount of work involved in harvesting it,
Oh, it's intense. We're talking hundreds of thousands of tiny crocus stigmas for just 1 kilo, so it's incredibly valuable.
which unfortunately makes it a prime target for, well, fakes and poor quality stuff.
Exactly. How do you know you're getting the real deal, the good stuff? Not something, diluted or just plain fake.
That's the million-dollar question, maybe literally, with saffron. And for the global market, the answer really hinges on this key international standard, ISO 3632.
Right. This isn't just some dusty document. It's the agreed-upon set of rules.
The rule book for what makes saffron, and how to prove it.
Precisely. It provides that common language, the framework for testing. It's all about clarity and trust in a market where, frankly, a lot of money is involved.
So that's our deep dive today. We're using the sources you sent over to really unpack ISO 3632,
Yeah. We'll look at how it's structured, what quality actually means according to this standard.
how they test for it, how saffron gets graded, and really importantly, why this matters to you, whether you're, trading it or just love cooking with it.
Making sure you get what you pay for, essentially.
Exactly. Let's get into the science behind this red gold.
Let's do.
Okay, so starting right at the beginning, what exactly is ISO 3632? Fundamentally.
Fundamentally, it's the international standard just for saffron. That's Crocus sativus L, botanically speaking. It lays out the quality requirements and, critically, the methods for testing those requirements.
And it applies to the saffron we actually buy, like the threads and powder?
Yes, specifically dried saffron,
Mhm.
either in filament form, those are the threads, whole, or maybe cut, and also in powder form.
Okay. And our sources mentioned this actually in two parts. Why split it? Seems a bit complicated.
It is in two parts. It's pretty common for these kinds of technical ISO standards. So, part one, ISO 36321, that's a specification. Think of it as the blueprint. What should quality saffron look like on paper? The current one's from 2011.
So that's the requirements, the grades.
Exactly. Quality requirements, the classification system, category 1, T3, and guidelines for things like packaging, labeling.
Gotcha. And part two.
Part 2, ISO 36322, is the test methods. Current version's 2010. This is the practical guide, the how-to. It specifies the exact lab procedures.
But how to actually measure the color or spot impurities.
Precisely. How to identify it's really saffron, measure moisture, check for floral waste bits of the flower you don't want, or extraneous matter, dirt, whatever. And crucially, how to quantify those key chemical compounds.
So part one sets the target. Part two tells you how to measure if you hit it. Makes sense.
You got it. And splitting it gives them flexibility. Say there's a breakthrough in testing technology.
They can just update part two, the methods part.
Exactly. Without rewriting all the quality definitions in part one, it makes sure the specs are always backed by solid, standard, verifiable methods. You really need both parts for the full picture.
And who is this standard really aimed at? Does it cover, like, saffron used for industrial dye or something?
Good question. It explicitly says it's for dried saffron meant for direct consumption, or as a food ingredient, or for repackaging.
So the stuff we eat or cook with.
Right. It specifically excludes products intended for industrial processing. That tells you the focus is squarely on the saffron, where color, flavor, aroma, the sensory stuff is key. Not, say, bulk extraction, where other things might matter more.
And it's not new, is it? It's been around and evolved.
Yeah, definitely not static.
Yeah.
Efforts started way back, like 1980. Then it evolved into the two-part structure we see now, adding technical specs over the years. The current versions are 2010 and 2011.
And there's even a new update coming.
That's right. The sources point to a pretty major revision, ISOFD's 3632-1, expected around 2025. Big news there is the introduction of a formal extra class.
For the super premium stuff.
Exactly. Ultra premium. It shows the standard is alive,
Hmm.
adapting to science and what the market actually needs.
Okay, so we know what it is, how it's structured, but let's talk impact. In the real world, the global trade, why is this standard so important?
Oh, it's absolutely critical. It's the global benchmark. Everyone recognizes it.
So it builds trust between buyers and sellers.
Totally. Think about trading something this expensive across borders without any agreed upon rules. Chaos, right?
Yeah, disputes waiting to happen.
ISO 3632 provides that common language, that shared methodology. It cuts down massively on ambiguity, potential arguments. It just builds confidence, makes trade smoother, more transparent, essential for this kind of high-value stuff.
And the big one, does it actually help fight fraud, protect consumers?
Fundamentally, yes. Complying with the standard is the main way buyers get assurance they're getting authentic, quality saffron.
Proof it's really Crocus sativicel.
Exactly, and not some cheap filler or, dyed corn silk. It protects everyone, consumers, legitimate businesses, from dodgy products.
And given the price tag, I imagine people try all sorts of tricks.
Oh, they do. Adding cheaper bits of the plant, using artificial colors, adding sand or sugar for weight, you name it.
Seriously, sand.
Yep, adds weight cheaply. The tests in ISO 3632 are specifically designed to catch these things. Think of the standard as a key risk management tool.
So technically it's voluntary, like all ISO standards. But is it really optional in practice?
Not really, not if you're serious about international trade. The high value, the risk, the need for trust. It all means ISO 3632 compliance is pretty much essential.
The gold standard for the red gold.
You could say that, yeah. Major buyers will almost certainly demand it.
All right, let's get to the core of it. How does ISO 3632 actually define quality? What are the key things it measures?
It defines quality using a mix of chemical and physical characteristics. The most famous are those three key chemical compounds.
The chemical trio, I've heard that term.
That's the one. First up, crocin. This is the big one for color. It's what gives saffron that intense red and makes it such a powerful dye. It's measured using spectrophotometry.
Okay, spectrophotometry. Layman's terms. How does that work?
Good point. Basically, you shine a specific wavelength of light through a saffron solution. Then you measure how much of that light gets absorbed by the solution.
And different chemicals absorb different light.
Exactly. For crocin, they look at the absorption around 440 nanometers. More absorption means more crocin, means stronger color potential. The result is given as this E1Cn 1% value.
E1Cn 1%. What does that number actually mean?
It stands for the specific absorbance that's the E of a 1% solution measured in a 1 centimeter path length cuvette. It's just a standardized way to quantify how much of that light-absorbing compound is there. These E values are fundamental to the grading.
Okay, crocin, color. What about the other two? Taste and smell.
Right. The characteristic bitterness comes mainly from Picrocrocin. That's measured spectrophotometrically too, but around 257 nanometers.
And the aroma. That amazing smell.
That's largely down to Safranal. Interestingly, Safranal actually forms from Picrocrocin during the drying process. It doesn't exist much in the fresh flower. It's measured around 330 nanometers.
So these three numbers from this light absorption test are the main basis for the grades.
Yeah, they're the primary chemical markers for classification. But it's worth noting, like our sources point out,
there's more to it.
Well, yeah. Saffron's sensory profile is incredibly complex. Lots of other volatile compounds contribute. So focusing just on these three, while necessary for a standard, maybe doesn't capture the full, nuanced picture of flavor and aroma. It's a simplification.
That makes sense. A standard needs measurable things. What about the physical side? Purity.
Oh, absolutely crucial, both for the quality itself and for spotting adulteration. ISO 3632 sets limits for several physical things.
Like
moisture and volatile matter. Too much water is bad news. Max 12% for threads, 10% for powder. More than that, it degrades, can get moldy, dilutes the good stuff. Floral waste. This is bits of the crocus flower that aren't the red stigma, mostly the yellow-white style part. It has much less crocin, picrocrocin. Too much means lower quality, like a common way to cheat, frankly.
Just bulking it up.
Yep. Then there's extraneous matter. Anything that's not saffron at all. Dust, soil, bits of other plants, deliberate adulterants. Limits are strict, especially for top grades.
And ash. You mentioned sand earlier.
Right. Ash content. They burn the saffron and weigh the inorganic residue. Total ash is the overall mineral content. But acid-insoluble ash is key.
Why acid-insoluble?
Because that specifically measures things like sand, soil, silica, stuff that won't dissolve in acid. A high reading here is a huge red flag for deliberate adulteration, adding dirt to boost the weight.
Wow, so those physical tests are like a first defense against the obvious cheating.
Absolutely. They nail the crude fraud attempts and check the basic integrity. Essential.
Our sources also really drill down on the specific parts of the plant. The stigma versus the style. Why is that so important for the standard?
Because the value is concentrated in one part. The saffron pistil has the stigma at the top and the style connecting it down.
And the good stuff is in the stigma.
Exactly. The stigma, that deep red thread tip, That's where you find the highest levels of crocin, picrocrocin, safranal precursors. That's the prize.
And the style, the lower bit.
The style, the yellowish or whitish thread below the stigma, has significantly lower levels of everything important. It's just not as potent.
So including too much style is basically watering down the quality.
Precisely. It adds weight but not value. So the standard defines these parts clearly. This lets them set limits on floral waste, which is mostly style, and define different forms of saffron in the market.
Like filaments versus cut filaments.
Right. Filaments usually means the stigma plus some attached style. Cut filaments means they've tried to remove most or all of the style, so it's primarily just the red stigmas, usually higher quality.
And powder.
Powder is just ground up filaments. It has to meet the same chemical standards, but testing, especially microscopy, is super important because you can't see if there's too much style or other junk mixed in once it's powdered.
Makes sense. Clear definitions stop people from hiding low-quality bits, especially in powder.
That's the idea, essential for fair grading.
Okay, so we know what they measure. How do labs actually do these tests, according to ISO 3632 Part 2?
Well, following the methods precisely is key for getting results that are reliable and, crucially, comparable between different labs worldwide. It all starts with sample preparation.
Not just grabbing a pinch.
No. You need a representative sample from the batch following specific rules like ISO 948. Usually need about 10 grams minimum, and you have to prep it quickly.
Why quickly?
Saffron sensitive. It can absorb moisture from the air or lose those volatile aroma compounds if left exposed. So steps like drying for moisture tests or grinding and extracting for the chemical analysis need careful handling to make sure the test reflects the actual batch quality.
Then the big one, the spectrophotometry for the chemical trio.
Right, the spectrophotometric analysis. That's where they measure the light absorbance at those specific wavelengths. 440 millimeter for Crocin, 257 millimeters for Picrocrocin, 330 millimeter for Safranal.
And that gives the E1C ME1% values.
Exactly. The calculations factor in the sample weight, moisture content, how much it was diluted. And for labs doing this for trade, getting accredited to ISO IEC 14025 is pretty much expected for credibility.
But didn't we talk about some scientific debate around this method? Some reliability concerns?
Ah, yes. This is a really important point and where it gets a bit tricky. While it is the standard method, there are known limitations, especially for Picrocrocin at 257 millimeter and Safranal at 330 millimeter.
What's the problem?
The issue is selectivity. Other compounds naturally present in saffron also absorb light near those same wavelengths.
So the machine might be reading the noise as well as the signal. It's
Yeah.
not just measuring the Picrocrocin or Safranal.
That's a good way to put it. There's interference. This can lead to the results overestimating the actual amount of Picrocrocin and Safranal.
Overestimating. So a sample might seem better quality than it really is based on those numbers.
That's the concern highlighted in the research. Yes, it can cause analytical errors, make it hard to truly distinguish between very similar samples, and could even affect things like PDO's protected designation of origin, which rely on specific quality profiles measured by this method. It's a classic case of a widely accessible method versus the need for higher analytical precision.
Seems like a fundamental challenge. What about the other tests, like looking under a microscope?
Right, microscopic examination. This is also specified in Part 2, and it's vital. It does two main things. First, it confirms the material looks like saffron.
Like the cellular structure, Colin.
Exactly. Does it have the characteristic features of Crocus sativus L? Second, and maybe even more importantly, it's used to spot physical adulterants, foreign matter.
Like you said, dyed corn silk or bits of other plants.
Precisely that kind of thing. It's a crucial quality check, a gatekeeper. If the analyst sees stuff under the scope that clearly isn't saffron, boom, it can be rejected.
Sometimes without even needing the chemical tests.
Potentially, if it's blatant. It's especially critical for powder, where you lose all visual cues. Needs a skilled eye, but it's powerful against crude fraud that might not immediately throw off the chemical readings.
And those physical purity tests, moisture, ash.
Yep, Part 2 specifies methods for those two, often referencing other general ISO standards. Moisture is usually oven drying, total ash, burning it off in a furnace, typically following ISO 928.
And the acid-insoluble ash for the dirt.
That's using ISO 930, treat the ash with acid, see what doesn't dissolve. Floral waste and extraneous matter in filaments are often done by hand, careful separation, and weighing. There's also a test for cold water soluble extract, ISO 941.
What's that for?
It can help pick up things like added sugars, which dissolve in cold water and add weight. They're mostly straightforward, robust physical tests, good tools against basic economic cheating.
So the standard doesn't exist in a vacuum. It points to other ISO methods too.
Correct. These normative references are important. It uses established general ISO standards for things like ash or sampling that apply to many spices.
For consistency.
Exactly. Ensures labs use the same basic procedures across the board. Avoids reinventing the wheel for every single spice standard. It just means labs working with Saffron need to know these other reference standards too.
Okay, so the lab runs all these tests, the spectro, the microscope, the physical checks. How does ISO 3632 use those results to actually classify the saffron, to give it a grade?
Right, classification is a primary goal. It provides that quality framework. It takes the results, especially those E1CM 1% values for the chemical trio, plus the impurity levels, and assigns the saffron to a specific quality category.
And what are the standard categories we usually see?
Traditionally, there are three main official ISO categories, numbered 1, 2, and 3, in descending order of quality. You sometimes hear about Category 4 in the market, but that's generally for stuff that falls below the minimum for a 3.
So Category 1 is the best.
Category I, yes. Highest quality. It demands the highest minimum levels for Crocin, Picrocrocin, and Safranal, and the strictest limits on things like moisture, ash, and floral waste.
Do you have the numbers for Cat time?
Let me see. Sources typically indicate minimums like Crocin 200, Picrocrocin 70, Safranal 20, and low impurities. Max moisture 12%, acid-insoluble ash maybe 1%, floral waste D0.5%, things like that.
Okay. And Category 2?
Category 2 is moderate quality. Still good, but the minimum chemical thresholds are lower, like Crocin 170, Picrocrocin 55. Safranal minimum often stays at 29. Impurity limits might be similar or slightly relaxed compared to Cat 1.
And Category 3?
Category 3 is the lowest quality level officially recognized by the ISO standard. Minimums drop again. Crocin maybe A120, Picrocrocin 40, again, Safranal often no 20. Moisture usually still capped at 12%, but maybe a bit more floral waste or ash allowed. An interesting point is how those minimums work. Crocin and Picrocrocin really differentiate the categories, but the minimum Safranal level in the current standard can be the same across I, 2, and 3.
That is interesting. And you mentioned earlier, even within one category, say Category I, there can be a big difference in quality.
Oh, absolutely. A sample that just scrapes into Category I with, say, a Crocin of 205 is worlds apart from an exceptional one with Crocin up at 280. They're both technically Cat I, but
not really the same quality in practice.
Exactly, which is why discerning buyers often specify minimum values they want within a category, not just the category itself. They might say Category I, minimum Crocin 250.
And this leads back to that upcoming extra class, to recognize the really top stuff.
Precisely. That proposed update, ISFTI 3632-1, wants to formalize an extra class above Category I. It's driven by the market wanting to differentiate that truly ultra-premium saffron that blows past the current Cat I minimums. Makes sense, right?
Yeah.
The FA8 Codex standard already has an extra class too.
Yeah, totally. And I recall seeing research proposing even more grades, like subdivisions within Category I.
That's right, especially research coming out of places like Italy, where they consistently produce very high-quality saffron. They're suggesting ways to subdivide Cat I further, maybe premium, superior, high quality, based on finer differences.
Trying to get credit for exceptional quality.
Essentially, yes. It's about producers wanting recognition for product that's significantly better than just meets Cat I. It's not official ISO yet, but these ideas definitely feed into how the standard might evolve.
Now, how do these ISO categories line up with the names people might actually see when buying saffron, especially those traditional names from Iran, a huge producer?
That's a really practical connection. Those traditional Persian names are still very common, and they add another layer. They often combine a sense of quality level, correlating roughly with ISO grades, but also describe the physical form or cut of the saffron threads.
Like Nagin.
Exactly. Nagin, or sometimes super Nagin, is usually considered the top visual grade. Long, thick, all red stigmas with almost no yellow style attached. This generally corresponds to ISO Category 1. The name supposedly means diamond on a ring, suggesting its value.
Okay, Nagin is top visually. What else?
Then you have Sargal. This means top of the flower. That's also all red stigmas, but they might be shorter, maybe a bit more broken than Nagin. Quality-wise, usually ISO Category 1 or maybe high Category 2, depending on the actual chemical test results.
And Pushel. I've heard that one.
Puschel, or sometimes Lutsche.
Oh,
This grade explicitly includes the red stigmas plus a noticeable amount of the yellow style, maybe 1 to 3 millimeters still attached. Because of that lower value style content, it typically falls into ISO category 2 or 3.
so visibly lower quality.
Yes. And then at the bottom, you have bunch, or dosta. This is basically the entire saffron pistil stigma, the full style, sometimes even the white base part, all bundled together. Lowest quality cut, often ISO category 4th, or maybe even below the minimums for Cat 3.
Are there other names too?
You might hear mongra, which is a term often used for high-quality Kashmiri saffron, typically all red stigmas, similar in concept to Nagin or Sargal.
So in practice, buyers might use both systems.
Very often, yes. They might specify ISO category I Nagin cut. That way, they're defining both the scientifically tested quality, ISO grade, and the desired physical appearance and style content, the cut.
Okay, so you've grown it, harvested it, tested it, graded it according to ISO. Phew, but it's not over yet, is it? How does the standard address keeping that quality high after testing? Packaging.
Absolutely crucial final step. Yes, ISO 3632 includes requirements for packaging. Basically, containers need to be clean, airtight, and moisture resistant.
Why those specific things, airtight, moisture resistant?
Well, saffron has two big enemies, moisture and air. It's hygroscopic, meaning it sucks up moisture from the atmosphere like a sponge.
Like Crocin.
Leads to caking, degradation, potential mold, bad news. And the aroma compounds, like Safranal, they're volatile. If the container isn't airtight, that gorgeous aroma just escapes, vanishes.
So you lose the smell.
Yep. Plus, good packaging protects from contamination, and ideally light too, since light can fade the color over time. The standard also mandates clear labeling, gotta state the ISO grade accurately if you're claiming compliance.
So even if you have certified category I saffron, if you package it badly.
It won't stay category I for long.
Exactly.
All that hard work in cultivation and testing can be undone by a leaky container. It really highlights that quality management needs to run through the whole supply chain.
Right. Now, let's circle back to something we touched on earlier, those limitations with the main chemical test, the spectrophotometry. That scientific debate. Can we unpack that a bit more? How serious is this issue of lack of selectivity?
It's definitely a point of contention, particularly for those focused on very precise quality assessment and differentiation. The core problem, again, is that at the wavelengths used for Picrocrocin, 257 millimeter, and Safranal, 330 millimeter, other saffron compounds also absorb some light.
Interference, basically.
Yes. So the spectrophotometer reading isn't just from the compound you're interested in. It includes absorbance from these other interfering compounds, too.
Which means the final number can be artificially inflated.
That's the concern. The test might suggest higher levels of these key flavor and aroma compounds than are truly present.
So the standard's main test for taste and smell strength could actually be misleading.
Potentially, yes, according to the research. It can lead to analytical errors, makes it genuinely harder to distinguish between two samples that might have slightly different real profiles, but similar absorbance readings. And as we mentioned, it can complicate things for geographical indications, trying to guarantee a specific sensory quality based on these potentially inflated values.
So what's the alternative? What are scientists pushing for? What's the future look like for testing?
Well, this is where the more advanced analytical techniques come into play, largely driven by these limitations. The big one being pushed is HPLC, high-performance liquid chromatography.
HPLC, how's that better?
HPLC is much more specific. Instead of just measuring total light absorption at one wavelength, it first separates the different chemical compounds in the saffron extract. Then it detects and quantifies them individually.
So it isolates the Picrocrocin before measuring it. No interference.
Exactly. You get a much more accurate quantitative measure of the specific crocins, the real Picrocrocin level, and other key compounds. It provides a detailed chemical fingerprint of the saffron.
Which is better for authentication, too. Spotting fakes.
Definitely. It's much better at detecting specific adulterants, like certain synthetic dyes, that might not show up clearly with the basic UVV spec method. Some sources even mention a draft codex standard looking at using HPLC specifically for dye detection. You see quotes from researchers literally asking, why aren't we using liquid chromatography? It shows the scientific pressure. Another technique getting attention is FTNIR spectroscopy, that's Fourier transform near infrared.
That's complicated.
It's actually quite fast and, importantly, non-destructive. Uses infrared light. Research suggests it's good for rapid screening and can even differentiate within those premium category I samples. Then you have things like GCMS for super detailed aroma analysis, electronic noses.
Wow. Okay. So much more sophisticated tools exist. Are they being used widely?
That's the bottleneck. While they offer huge advantages in accuracy and detail, HPLC, GCMS, they require significantly more expensive equipment and highly trained analysts compared to a basic spectrophotometer. So widespread adoption globally takes time and investment.
So it really sounds like the standard ISO 3632 is very much a work in progress. It's not static.
Not at all. It's a dynamic field. Research is constantly pushing for stricter limits for those finer grade subdivisions we talked about, and strongly advocating for incorporating these more accurate analytical methods like HPLC into the official standard.
And the upcoming revision with the extra class is proof it's responding.
Absolutely. It's clear evidence the standard is evolving. It's reacting to market needs for better differentiation at the top end, and it's listening to the scientific community's call for greater accuracy and reliability in testing.
So what's the big picture takeaway from this evolution? Where is it all heading?
The clear trend is towards more sophisticated evaluation, moving beyond just those three potentially flawed UVVs numbers to a more multifaceted assessment. Future versions of ISO 3632 will likely incorporate new methods, maybe new categories.
Making it more complex.
Probably, yes. Demanding more from testing labs in terms of tech and expertise. But that evolution seems necessary, right? To keep pace with science, with technology, and, frankly, with the people trying to cheat the system. It's all about protecting the integrity and the true value of real saffron.
Wow, okay. This has been a fascinating deep dive. It's amazing how much science, how much careful standardization goes into ensuring the quality of what seems like just a tiny thread of spice.
It really underscores the vital role of ISO 3632. It's that foundational standard that enables trust and fair trade in this incredibly valuable red gold market globally.
Yeah. And we've seen it has its limitations, especially that core testing method. It's not perfect, but it's definitely not set in stone either.
Not at all. It's a living document, constantly being poked, prodded, refined.
That push for more accuracy, for better ways to define top quality like the extra class, exploring advanced testing, it's all part of its ongoing story.
Exactly, and that evolution is absolutely essential for it to stay relevant, effective against increasingly sophisticated fraud, and ultimately to reinforce the true value and integrity of genuine saffron.
Indeed. So when you think about all this, all the layers of testing, the precise definitions, the grading, the constant scientific debate and refinement needed just for this one spice, what does that tell you about the effort involved in guaranteeing quality for any high-value, sought-after product in our global market today? Is seeing that ISO grade on the package the end of the story? Or does knowing about all this complexity actually make you ask more questions about how that quality was really defined, how rigorously it was tested, and whether the standard itself is truly keeping up? Something to think about next time you reach for that precious, incredible spice.